Okay, so this new unit called parameters, return and libraries is actually unit 7. And the reason why we are skipping unit 6 is because unit 6, while it is a fine unit, it is not as applicable to your create tasks, which are the projects that are coming up shortly, which don't worry, we have plenty of time in class to do it. But the unit is entirely offline. It has some important concepts that will be on the AP exam. And if you're not taking the exam, still just important in general to computer science. But it is not programming. It's not a programming lesson. It's just sort of computer science concepts, which, like I said, are fine, but they aren't going to help you with your project. So we're going to skip or postpone lesson 6 and move on to lesson 7, which after unit 7, which will lead us into the create task, will be the next unit. And we will have plenty of time to work on it. Okay, it will probably straddle spring break. But once it's done, we will have time that we can prepare for the exam and do the other units that are more exam focused. Okay, so we are jumping straight to unit 7. And the format for this unit is same as the last one, where in 4 lesson increments, there is sort of a general introduction, investigate some examples, do some basic practice and then more advanced practice, and then combine it all into a sort of mini project. And it will do that for all 3. Well, I guess the second one isn't really its own unit, but we are going to try and make it through 1 through 3 today. That's the goal. So starting with lesson 1, it's just a basic introduction. Go ahead and do screens off, phones away, headphones away, laptops closed, find somewhere comfortable so that we can watch the basic introduction video. It's only 3 minutes long. I think you can handle it. Let's see if
so far, we've been using functions to make it easier for a program to do the exact same thing lots of different times. But sometimes we want a function to do things a little differently each time. Maybe one.
Give me a second here. Why is this not
each other, even if they're not exactly the same.
So like this, and we'll go like this, and we'll go like this, and please work. There we go. All right.
By using code.
Right there. All right. This time for real.
So far, you've been using functions to make it easier for a program to do the exact same thing lots of different times. But sometimes you want a function to do things a little differently each time. Maybe one time you want a star element to move, and the next time you want the moon to move. Or maybe you want to change the color of everything on the screen to green, but later red or blue. Writing a new function for every element or color you might want to use would take up way too much time. So how can we create a function that does almost the same thing, but with tiny differences? To do that, programmers use parameters. A parameter is an extra piece of information asked to a function to customize it for a specific need. Let's take a look at how they work. Imagine you created 2 functions, one to move a bike across the screen and another to move a motorcycle across the screen. These 2 functions are almost exactly alike. They both use get property to find the x position of the element, and they both use the counter pattern to add 5 to the x position. The only difference in these 2 functions is that one uses bike and the other motorcycle. When you have 2 functions that are almost exactly alike, but with one little difference, that's a great time to use a parameter to combine the 2 functions into one. To start off, we'll need the function block that includes a parameter. Since we don't know whether we'll be moving the bike or the motorcycle, let's just call the function move vehicle. To figure out what goes inside, we can look at the two functions that we already have. We'll definitely keep the code that's the same in both of these functions, but the parts that were different will need a parameter. A parameter is a lot like a variable that we can only use inside the function. So we'll want a descriptive name, like vehicle. Also, like a variable, it doesn't need quotes around it. Last, we'll change the default parameter in the parentheses to our parameter name. Now that we have our combined function, it's time to test it out. When we call our function, we use the parameter to tell it whether we want the bike or the motorcycle to move. This time, let's move the bike. Now, every time that the parameter shows up in the code, the program will use bike instead. When we pass in motorcycle, the best thing about using parameters is that we can use this function with any element, even ones we haven't thought of yet. Let's say we wanted to add a space shuttle to our code. We can add the shuttle image in design mode with the ID shuttle. Now, we can use the same function to make the shuttle move across the screen, even though we hadn't even thought of the shuttle when we first wrote the function. Instead of creating 3 different functions, we've used just one, and it will work with any other elements we add to our screen. Parameters let us use the same code to solve problems that are similar to each other, even if they're not exactly the same. By using parameters, you can save yourself time and make your functions even more powerful.
Okay, so if you were in my class last semester, you can get your computers going. Everyone can. But if you were in my class last semester, we did the digital scene project, the under the sea thing, where we did actually use parameters there, but in that project, we only used numbers. The only data type we ever sent as a parameter was a number, which was useful. It's, put the different things in different places on the screen and that sort of thing. But it can be used for any data type. Okay, you can send it strings, you can send it entire lists. You can send you can send any data type. That's all I have to say is any data type. So let's look at some examples. Go ahead to lesson 2, bubble 1. And we have this is the calculator app. And let me refresh it so it looks like the way it looks like for you. This is actually a calculator app that takes 2 user inputs and runs whatever arithmetic is needed for that, and outputs. Can you stop with the disk tray? Thanks, man. It outputs the entire operation along with the result and gives you this nice little tidbit of whether or not the result is odd or even. And we'll take a look at how it works. The entire app is this one function called calculate. And it is useful for all 3 of these arithmetic operations because it receives a parameter. The app can call the same function, sending it a different value each time. And based on what gets sent, it goes through this conditional and checks to see if an addition symbol, a plus sign was sent, a subtraction minus sign, or multiplication was sent. And based on that, it does the arithmetic and puts it into a variable called answer. Now, it is being sent a string. Like this is the character plus sign. This is the character plus sign along with a space on either side. It's not the operation plus or addition, but the conditional here uses that character, that string, in the condition where if a plus sign was sent, it's received in this parameter called symbol, and it checks if symbol is a plus sign, it does an actual addition. Okay, this plus sign right here is actual addition. This plus sign is just like the character, the shape plus sign. And it's checking that. Okay, if it's not a plus sign, it checks to see if it's a minus sign. If it is, it does subtraction. If it's not, it knows at this point, the only other option is multiplication. So it runs multiplication. All right. Then it does this little, I don't know, side feature where we've seen before modular arithmetic, where any number mod 2, if it's 0, that means it's even. Remember, modular arithmetic, modulo is division, except the answer is the remainder. And anything mod 2, if you divide by 2 with no remainder, it's an even number. If you have a remainder, which would be remainder 1, assuming your first number is a whole number, a remainder 1 means it's odd. Okay, so that's how we get this, like, your answer's odd, your answer's even situation. Then the way it gets the output is this variable answer, which at this point is just whatever the arithmetic is, gets the user's number 1, followed by space, followed by whatever character they sent, followed by space, followed by the other number, followed by an equal sign, followed by whatever answer was after this, and puts it all together. All we need to do is add a button for division. So first thing we need to do, we need a division button, which you can drag out a new button and try to shape it, or you can just click on one and do duplicate, and it'll give you all the same parameters, or yeah, all the same properties. So let's call this one division button. And I haven't been able to find a useful division icon. I don't think so. Percent. Yeah, well, percent would be modular, it'd be something else. Let's in the other class we just put, let's just have the character. Let's get rid of the icon and put a slash in there, and let's make the text color black. And wow, everything's all over the place. And font size. And is there an embolden? That's fine. I don't know. This is just window dressing. It's not super important. Okay, so we have a new button. It's called division button. And all we need to do is the same thing, except slightly different as the other ones. We need an event handler. On event, division button clicked. We want to set the output label to run calculate, but send it the character slash, or really we could send it the character anything, because it's not actually using this character in the arithmetic. It's using it in the conditional, which we need to add a row to our conditional, where we could add a conditional to check for multiplication, and then our only other one would be division. Okay, because of the way the buttons are set up, it has to be sent. It has to be either plus sign, minus sign, multiplication, and if it's not, it's the other one. But let's just add the conditional for division, and that will leave multiplication as the remainder. So if symbol double equals whatever we would send it, which is quote, the string space slash space, that is exactly what would be sent. Space slash space in quotes. If that happens, we want to set answer to do that actual arithmetic. Answer gets, let's spell things correctly. That is a critical component. We want to set it to number 1 divided by number 2. And this is actually doing the arithmetic of division. And so let's see if it works. And There we go. And so it works. Okay, this is kind of a return function. Well, no, it is a return function. And we haven't really expressed what it means to be return. Later on when we get to libraries, it'll be a lot clearer, but the idea is it's not calling the function and then setting the text to whatever variable. We are calling the function in the output location because this function called will equate to this one long string, this concatenation. Okay, and if that was a little confusing, that's fine. This is just like in the past where we jump in a little bit farther. All right, so next app. This app I think is probably one of the best that we get as an example. It's I'd call it borderline useful as far as like a real world application. And the way it works, we give it a length of word and a letter, and it sorts through an entire word list, which is provided from the data table, and gives you every word that is that length and starts with that letter. It's pretty neat. Like I said, there are, I guess, various games that would need something like this, crossword, etc. And yeah, there you go. All right, so how does it work? Well, we already have the data table words given to you, which let's see how long it actually is. We can console log word list dot length just for fun. And it is several thousand words long, 4,953 words. Great. It's not super important to know how many there are, but to have some sort of scale and understanding its relevance is useful. And so the whole basic idea is we are calling a function. This function filter is receiving two parameters. All right. And the two parameters are the user's number and the user's letter. It is critical to know the data type. Okay. The first one has to be a number in order to work. And even before we look at how it's used, we know that if it's the user's number, that parameter has to be a number data type. And the letter has to be a string, which means it is important to do the get number versus get text situation. Okay, there are a couple of actually kind of neat things going on here. There is a waiting image, which is this hourglass, which is inside of the same function. It has show the waiting image, and then at the end it has hide the waiting image. What that does is, because the commands are done in order, it shows it, and then during the time that it takes the program to filter that long list, that waiting image is up, which is kind of satisfying, I would say, from a user perspective. The other thing it has is a very barely visible text area called unclickable that is on top of these drop downs, and you can see it's right there, and it starts out hidden, and during the time the program is running, just like when the hourglass is showing, it makes that element visible, which prevents the user from clicking on the drop downs while the app is running or while the filtering is happening. And at the end, it hides it so they can click on it again, which I think is kind of clever. We haven't seen anything like that yet. All right, so how does it work? Well, anytime, right off the bat, it runs it with A and 1, which is only one word that starts with an A and is one letter long. And which I think is, I don't think we even need this. I mean, you don't need to delete it, but I'm saying from the app situation, it doesn't really, hold on, does it not work if it's not there? Oh yeah, probably doesn't work there because it is, it needs to hide the other thing. But either way, anytime it's called, anytime either the number dropdown is changed, okay, length dropdown is changed, or letter dropdown is changed, it calls the function filter. It gets the user number as the first parameter and the user's text, which is really just a single letter, from the second dropdown. It does to lowercase as a method, because anytime you're doing some sort of conditional and you're matching against an inconsistently capitalized set of strings, it won't match if it's a capital letter versus a lowercase letter. So in order to increase the likelihood that it matches, you either go upper or lowercase, which we've seen stuff like that before. Okay, when the function receives the parameter, whatever number was in the dropdown gets passed as the first parameter, gets received, and put into what essentially is a local variable called length, or len. Then anywhere else in the project that you use len will be the number the user gave. And the same thing with letter, will be the string of the letter they gave. Okay, so we're working with a filtered list. That's just like before. And this functionality, this list traversal should look very familiar. It's essentially what we did in the last unit, where we run through an entire big list, word list.length, and we're checking for two things. If the word in the word list, okay, so the thing from the big list is index I, we're checking each of the things in word list. If it's dot length, because strings have a dot length property also, is the same as whatever number got sent as the first parameter, len, and the first two characters of whatever word we're looking at are the same as whatever letter was sent, it's a match, and it gets added to the filtered word list. Goes through every single word in the word list, and anytime both of these things are true, it gets added to the filtered word list. And if you recall, substring parses a larger string and returns whatever characters, and substring 01 is just the first character. And the first character of whatever word we're looking at. We're comparing each against the parameters being sent. If it's true, it goes in the filter word list. After that runs, if the filter word list is empty, if its dot length is 0, it adds a no options available, and then does the output with a dot join, which is how it puts them all in there. Okay. Our goal for this one is to get rid of the drop downs as an input and add a text input as an input. But this will allow the user to put in several letters and return all of the words that start with the letters the user has put in, which is a very similar app, but not quite, and requires obviously some different coding and some different design elements. We can go ahead and get rid of our drop downs, which I'm going to save the unclickable thing. I'm not sure if we'll use it in a second, but it's fine. And we're going to need a text input. Let's call it, I don't know, user text input. Doesn't matter. User text input. User text input. You can call it something else if you want. That's fine. And so the event we're looking for is something to do with this. Let's, I'm not going to delete this stuff, although all of this stuff already is useless because they are both, or all three of these calls to filter are expecting to get number from dropdowns that don't exist anymore. But just for fun, I'm going to comment it out instead of deleting it. You can delete those first three. Well, actually, whatever, just delete it. We're not going to use it. Yeah, if you already deleted it, that's fine. Okay, so we only have one event. And that event is when the user text input is we don't want on click, which we'll just have let's have a console log to, can I see it? Console log of the user's text of get text from text in user text input. Okay, if we have it set to click, that means it's going to run then, but it doesn't run when you type. The actual event we're looking for is input. And that way it will run every time anything is put in, which is what you're looking for. We want this app to filter every list every time the user adds a character, which you can see down here is happening. It also searches every time they delete a character with that new string. And so that's what we're looking for. We're looking for input. And that is a great way to use the console log eventing. Okay. So what do we want to do? Well, we want to have the set the text. One second. What we can just call the function, right? Is that all that was there? So we can just call the function, invoke the function. It's already named filter. And we need to send it. We're only interested in the one character or the one string that they use. So we are going to get text from the user text input. Okay, so we're calling filter and we're sending that function whatever is typed in there, and we're calling it every time the user types anything. So let's look at the function called filter. We aren't expecting two parameters. We are only expecting the one parameter, so we can get rid of one. And the other one, length, is not a good descriptive name for the entirety of the user's text. How about let's just call it user text. Now, when I was learning a lot of this stuff, people that were explaining or teaching, I don't think did a good job of explaining when words were required to be used and when it was just sort of convenient or, descriptive. And so I might use the, as the name of the parameter as text or something like that, but I don't want you to get confused with does this word have to be the data type, or does this word have to be some other word from syntax? I'm going to use words that are names for parameters, just like with variables, that are clearly my own. And when it's something that's clearly my own, it can be anything. It's just we use things that make sense. So even though text would be a good name for a parameter, user text, if I spelled it correctly, just let you know that whatever we call it here is its name. Now, whenever we call filter, we send it the user's text. It gets put into this parameter, which essentially is just a local variable. And anywhere in this function, we use the word user text, it will be whatever got sent to us. So let's see what we've got. We've got, okay, well, the hide and show thing is fine. That's good because it takes a while to filter. We've got an empty filter list. It clears out the text output every time it filters, so it's not like adding on top of things. Now, this is our issue. Okay, we are no longer looking for the length of a word or the first letter. We want to go through the entire list. Okay, we're checking every word in word list. And we want to check what? We want to check if, and actually I don't usually do this, I'm going to drag out the equals thing just because it will be easier to build things. What are we checking? Well, we want to append to the filtered word list if the user text, which is going to be a few characters, presumably what the user wants to start a word with, against the first few or however many letters of each word in word list. And how do we do a portion of a word? We do substring. Okay, so we want a substring of what string are we looking at? Each word in word list index I, because word list is the full list and word list index I is each one we look at as we go through the loop. And the substring, well, we know the first character. If we only wanted the first character, it would be substring 0,1. But we want to be able to check against however many characters the user gives us. So how do we know how many they give us? They give us user text.length number of characters. So our parameter for substring is substring 0, comma, however many there are. Now, this is a weird situation where it could be like user text.length +1 or -1. If you do just sort of the basic logic test of if the character sent us, or if the user gave us one character, we would want to do that first character thing, which is 0,1. So we know, just thinking about that the second parameter is however many characters they sent us. Okay, being able to figure out when to do .length -1, I +1 or whatever, when you're shifting things back and forth, you just think about a very basic idea. Does it need to be shifted 1 over or not? Okay, so if whatever they give us matches the substring of the word, a substring the length of whatever they give us, we want to add to our filter word list that entire word. Okay, so the append item, we want the whole word as we go through the entire list, if it matches just this first portion. Let's see if this works. It might. Nope, nothing starts that way. There we go. Apparently kite is not on this one. So it's not a comprehensive list. So we have the other issue of if you do A, you get this big pile. And if you do capital A, you get a different one, which may or may not be what you're looking for. I don't think it's the worst thing to have a 2 uppercase, 2 lowercase, or not. Like these are words, like maybe you are looking for proper nouns that start with a capital letter. But the thing I don't want is, so you add, you look for some words, you delete again, it gives you the entire list. The entire list is there. I don't want that. The way we're going to do that or deal with that is we are going to prevent this function from running if this .length, if the length of the user's text is 0, meaning it's empty. Because we are trying to run this function every time they click something, even when they delete the last letter, we are getting that empty string and checking against everything, and everything is true. So if we want to sort of protect that function from running, we need to put it in a conditional. What are we checking for? Well, we are doing a conditional based on the get text. Let's just make a short single use variable. Let's call it, I don't know, input text. This is a local variable. And this is who's going to get the text. And then we can check each time if input text is greater than 0. Oh no, input text.length is greater than 0. We can then run filter and send it input text because that's holding the get text. Now, when you run it, it should. You go back to 0. And oh, so it goes back to 0, but it doesn't clear out the last one. So how are we going to clear out the last one? Well, we can add an else, which is a condition if it's greater than 0, or no, if it is 0, the only way else is here is 0. And how are we going to blank it out? Well, we can just set the text of output, it's the name of that text area, to an empty string. Now, when you have a letter and go back, it's an empty string. Or you could have something a little cheekier, like please enter a letter or something like that. Give them a little side note. Yeah, there you go. Okay, so there's that one. The check for understanding for this one we can do together. It's another oh no, we'll go back to the last one for a second. So this one is a reflection, and just like in the past, they've given you check for understandings that I consider past where you would be at this point, asking you to explain the benefits of writing functions that use parameters and returns. We've been doing it for like 15 minutes. I don't expect you to be there. The one that I do want to do is the check for understanding from lesson 1, and we can do that together. It's another like follow the parameter situation. That is a useful skill. And so let's take a look. So we have the only action here is a console log statement that is a return function. Okay, and it is sending 2 parameters. Okay, it's sending the number 2, excuse me, the number 3 and the number 2. And this function called numbers is expecting 2 parameters. Whatever gets sent first is put into the parameter or local variable called num1, and the other one gets put into num2. No reason I can't make this bigger. Okay, and so what happens after this is run? So we have anywhere, well, let's just keep track of answer is our result we're looking for. So at the beginning, we have answer declared, nothing happens. This is an A. Okay, then answer gets the sum of the 2 numbers sent, which is 5. Okay, num1, num2. Then answer gets whatever it was before, which is 5, plus 3. So now it's 8. And we return answer, which is 8, times num2, which is 2. So we are returning 16, which is the answer. It's you wouldn't usually have further arithmetic in the return statement. You'd probably have answer gets answer times num2 and then return answer, just to be a little clearer for yourself reading the return function and the explanation. But at this point, I'm mostly interested in you being able to see some fresh chunk of code and follow the trail of what the variables are worth at the end. Okay, so let's jump in to lesson 3, bubble 1. And we've got some real basic use of parameters and return functions, like some console log stuff, which, this sort of real basic stuff, I think would probably be a better place to start than the last thing. But having seen the last 2 apps, the calculator and the Word app, you can see parameters in all their glory. And when you see them here on this real basic explanation or example, you have an idea of where we're going. So all we have here, we have a basic function called complement is the name of the function. It's expecting one parameter. And that parameter is called name. And the only thing it does is print out to the console whatever the user sent in the parameter, followed by you're the best. We just need to call this twice more to satisfy app lab. And it doesn't matter what you send it, it will print out, okay? When it calls the function, whatever is here, whatever is in the only parameter for this gets assigned, just like a local variable, assigned to whatever we call it here. In this case, it's name, which is I think a useful parameter name, and gets printed out. Nothing super exciting. We've already seen more difficult stuff than that. Okay, bubble 2. And bubble 2, we have a similar situation where the app is already set up to call two different functions, random greeting, random complement, 3 times each. First for Benjamin, then Raji, and then Esmeralda. So we can see the example called random greeting and how it works. And we need to make random complement work. And the only output we have right so far is random greeting. And even though it's calling random complement, there's nothing happening in here. So it just runs random greeting 3 times with the people's names. So how is this going to work? Well, we get a list as a local variable, which is strange to see a list as a local variable, but that's fine. That are a bunch of strings. And based on the string, you can tell that the user's name needs to go first, which is different than greetings, which are all set up to be the username last. So what are we going to do? We need a console log statement. That's our only output is console log. And what are we combining? Well, we're combining, the first thing we want is the name, which is the name of the parameter, name, concatenated by one, or concatenated with one of the strings that's in the list called complements. So how do you get one item, one anything from a list at random? It's going to be the name of the list at index. We need a random number. I'm just going to put a 0 in there right now, which obviously is not the final situation, but it will give me the block so I can drag things out. So if I said console log name plus complements at index 0, it would always give the incredible hair. Oh, it also helps to spell things. Is that the problem? Yeah, it always gives the first one, but we want to pick one at random. So we need to give this index a random number that corresponds to one of the indexes of that list. And you don't need to know how many items are on that list because the range of indexes is always 0 to list.length -1. And now every time we call it, every time it goes through the function, it will output a different complement to these 3 people. Occasionally getting the same one, but what are the chances of getting the same one? Well, it has to be 1. It depends how many there are. So, so there's that. That's all we need for this one. All right, let's go to bubble 3. And do we already do this one? No, we haven't. All right, so bubble 3 is similar to the last one, except it is generalized, and it is calling a return function inside of the concatenating with name, which to say this is an improvement on the last one is a kind of a stretch. It's not terrible. It's a more common, a more generalized way of using these functions. But I don't know. I think it's a messy explanation or example of how you would use both. It's just combining both of the calls instead of having one call for each of the functions for each person. You can call it in one. I don't know. It's just, it's abstraction, which is generally useful. I don't know if it's that super useful. Okay, so for this one, what are we supposed to do? Finish the code for random complement. So random complement, same thing as before, the list. We are just interested in essentially doing the same thing. We need to pick a random complement, and this is not concatenating. The concatenating happens inside of this higher level function, I guess. We just need a variable to pick one of these at random. And so let's call it random complement. And how do we pick one of these at random? It's going to be complements at a random index, which we can use random number at index 0 through complements.length -1. And random comp is defined. Oh, and then we need to send it back. Okay, so return functions, we need a return, and we're returning random complement. And how this works and why it works might be beyond you a little bit at this point, but it's fine. We're just sort of going through the motions at this point. But basic idea is that you use a return function because you can make it, it equates to an entire algorithm or the result of an entire process all in a single line. And just like regular functions where you have this generalized application, this like very useful, broad. Sure. Be quick. It's a way of doing all that in a very small amount of code. And it's sort of, you know, especially with parameters. So, especially when using parameters, it's sort of like, I kind of think of it as like a portal where it's sending that piece of information to somewhere else in your program, and it's sending back the answer all in a single line. I don't know if you see it that way, but that's how I visualize it, like little portals. And there you go. It's able to run everything together. Again, it's the usefulness of this particular application of return functions is dubious, but there we go. That's a use of a return function. All right, so now setting up functions that are even more generalized, allowing them to receive 3 parameters, in this case, a name, an age, and a birth month, which are a string, a number, and a string respectively. We want a the ability to return a season, and we are expecting the user to send a string that is a month, specifically capitalized, we're going to check against our known months, and they have given us which ones they're counting as seasons, and we will send back one of the seasons based on that. Okay, so even before it is, oh yeah, we do have month to season. And when we call month to season, it's sending birth month, which is being received as a parameter when it's called as the third parameter. Just to be less confusing, we'll call everything parameters. Technically, when it's called, it's an argument, but we'll call it a parameter. So the third thing here gets put into this temporary local variable called birth month. The way it's being used in this function is to send out to another function called month to season. We send it out and it gets returned as the season we want. So we need to write a conditional. And so it's going to be a long conditional with several, we have 4 outputs, right? 4 seasons. And so we want, what's the best way to do this? Well, we are, if month double equals, and we do a lot of copy pasting here. If month double equals January, or, and we can do copy a bunch of this stuff, month double equals February. I shouldn't have switched back to text mode. Probably easier in text mode. If month double equals January, or month double equals February, or month, and we need an or between each thing. Do we have the list up there? Yeah, let's go March. Then it needs to be capitalized. That's going to be our first possible output. And we'll go through the rest in a second. In fact, let's just go ahead and do them all. And it's probably easiest if you just copy your full formatting. And obviously we need to change some of these. Doesn't matter the order, but just for making things easier. April, May, June, July, August, and do they have it as, what do they have it as? Do they want it? Yeah, weird. October, November, December. I don't know why they do it that way, but that's fine. Okay, so we need a thing to return, and you can technically do return in each thing. The problem with putting return multiple times inside of a function is it ends the function also, which is a weird characteristic. But if you have it in a loop, and inside the loop you have a conditional, and that conditional ends up being true, and you have the return inside of that, the loop will stop. Here's not an issue because it's a simple situation, and the conditional can only be one of these 4. But so it's not a huge issue, but usually you wouldn't have return more than once unless it's something like return true, else, and then outside of it, you would have something like return false, like something like that. You might have multiple returns inside of the same return function, but we don't have that here. Let's make a variable to hold this. Let's call it a season. It doesn't matter what you call it. I'm using a unnecessarily custom name just to be sure. And we don't even need to declare this or initialize it. We could just do that's I don't know. It's just a habit of mine to initialize variables when you declare it with whatever data type. Either will work at this point. So it's a local variable. We're putting it right there. And each time we're deciding what we want, and we need to return the correct data type, which is a string. So winter, and then spring and summer. And we don't need to check for fall because it will only get there. It will only get there if all of these were false. And we are returning whatever got put in season. You could just call it season if you want. I don't know why. The reasons I said before about naming things in a clear manner that they're my own words and not syntax. Which, if you didn't know, syntax is the word, what it means, what is actually used by the program, like else and function. You can't name your functions functions. You can't name your variables functions. It's syntax. Okay, it also counts the punctuation is also syntax. With curly brackets and whatnot. So now, when this function is called name and age, that whatever's in the third parameter gets sent right here where we call month and season, which is a function we just made, and send it a string, and hopefully we will get a season. Yeah, there we go. In the winter, in the summer, in the fall. Now, if we sent it something that wasn't a season, what do you think is going to happen? You just go on how many passes. Any guesses what's going to happen if we send it something that's not a season? It's going to say fall, because what we send it doesn't meet any of these. And that is why you might want to do an if else at the end that actually checks for the fall months and only return fall, and have the else be like some sort of error message return. But I mean, that's just getting you to think about how conditionals work, where what happens if you send something that isn't supposed to be sent, or it's a string that's not expected, it works differently. But there you go. That's it for this one. That was fun. Okay, bubble 5. I think we can get through this, hopefully. Maybe not. Yeah, definitely maybe not. I think we will, well, let's see how fast this goes. Are there any other, is there another? Yeah, I think we'll just get through this stuff, and that will be where we deal with it for now. All right, so let's see what we got. We've got a program. We've seen things like this before. Longest word. Well, let's just see what happens. Okay, there are many states, but the one with the shortest, there are many dogs, but the one with the shortest name is Pug. And the longest one is unknown. All right, so it looks like we've got a couple of functions or a couple of situations, one for dog names and one for state names, where we are successfully accessing shortest word functionality, but not the longest word. We need to make it find the longest word also. It's making it happen by calling these higher level functions. So we have seen this, and we saw it before with parameters when we did the digital scene unit, where we had like draw all fish called draw fish, you know, however many times. And so parameters being in these abstracted multi-level function situations are common. Here, this top level function called longest and shortest sends two parameters. One refers to which list to get the information from. And, oh wait, no. Where's state? No, it's, states is type of list and list. Ouch. Where's type of list used? Oh, okay, so type of list is just used as part of the output, which is, there are many, the word states, but what's key here is the second parameter being sent is the entire list. Okay, the second parameter is the list of state names. This is the first time we're sending an actual array, a list, as one of the parameters. And then once it gets there, which will be the parameter list, a great name for it, it will have all the properties of a list and actually all that stuff. Okay, so first time we're calling it with state, second time we're calling it with dogs. And what's happening, we are running shortest word and giving it an entire list, which this entire function will turn into whichever word is shortest from whatever list we give it. So we have this entire amount of programming in this entire function is done in a single line right there. It turns into the word, the shortest word we're looking for. And that's how the Iowa and Pug is being returned. And the other one, we want to call longest word, send it a list, and have it turn into whichever word is longest. So we're going to do essentially the same thing, but with longest. And we've done similar things before, reducing, mapping, that sort of thing. I guess reducing to find the highest or lowest of something, the longest or shortest, the biggest or smallest, where the method is the same. We need a container to hold on to sort of the running champion for biggest or smallest, longest, shortest, whatever. And how are we going to do it? We need, let's give it a good name like longest. And this variable, we are not worried about, we're only worried about the length of the word when we're comparing it, but what we're actually interested in is the word. Our comparison operator will be a dot length situation, but we want to return, we're interested in returning the actual word, not the length of that word. So in order to do this process of starting with the first thing and comparing it against every other thing, we give this running champion, this variable that's holding the mostest of whatever we're looking for, the first item. Then we take that first item and compare it against every other item and replace that container or what's in that container with whatever we're looking at if it meets our condition. So we're going to give it the first word in the list, which is called list, at index 0. Okay, whatever list we send it, we're going to give our running champion variable whatever's in the first position. Now we need to loop. We need to go through every item in whatever list we send it, list.length, number of loopings. And we want to check the length of each item we look at. If list index I dot length, okay, list is full of words. Words have the dot length property. That's how many characters they have. If the word we're looking at is longer than longest dot length, because longest is holding the word, it's not holding the length of the word, it's holding the word. So if we want to compare the length of a word we're looking at versus our running champion for longest, if it is longer, we want to replace it. We want our running champion container called longest to get that new word, list index I. If the thing we're looking at is longer than our longest, we want to put it into the container that holds the longest. Then once we get through the end, whatever string is in that variable will be the longest. That's what we want to return. And what we call things in here doesn't matter. The fact that we've called this longest doesn't mean anything. It's just the name we gave it. It will return whatever is put into here. And that's what this entire return statement does. And we should be able to, yeah, there we go. So Iowa, and now we get North Carolina as the longest string. And we had Hug, and the longest one now is Caucasian Shepherd or Shepherd. Okay. So finish and a couple more, and we should fly through this. That'd be nice. It's a long lesson. All right. Populations. Yeah, we're definitely not getting through the whole thing. I think we can do these other ones. Might be close. All right, populations. Let's see what happens when we run it. In fact, we'll call this one the last one for today. I'm dragging. I'm guessing you are too. And people are already doing other things, so that's great. Okay, so we hit run, and there are many states. The one with the smallest population is, and the one with the largest population is unknown. Clearly, we need to do the same thing and sort through to find largest and smallest for populations. See what we've got. We've got our top level function. It's called largest smallest. We send it a string, which is just used to like make the sentence in the console log. And we send it two lists. Okay, it's receiving two different parameters that are lists. It's receiving three. The first one is whatever we want in the sentence. But with these two lists, we are doing that same thing that we did in the last unit, where we loop through and we loop through looking at everything from one list. And if something from that list meets some requirement, we want the thing in the same position of a different list. Okay, that was like essentially your entire project was looping through one list and getting things from the same position in a different list. So let's see what we have. Okay, so here is some good documentation of what comments should look like in a return function. First is an explanation, then what parameters are being expected and what data type. Okay, list one is expecting a list data type, and what's in that list? A list of strings. List two is a list, but it's expecting a list of numbers. Otherwise, it won't work. If you switched names and population, it wouldn't work because it'd be comparing strings and numbers differently. Okay, so it is creating two different variables. Well, let's just solve this one together. Okay, so just like before, where we wanted the longest word or the shortest word for a container for, you know, the running champion, we need two different containers, because even though we're comparing populations, we want the name of the state that has that population or whatever we send it. So list one is a list of strings. Let's call it a string list. And list two has to be a list of numbers. And let's call it num list. And oh no, it's not list because this is our container. The first one has to do with strings. Actually, these are just the containers. They can be anything. Let's just call it big string and big num. Okay, even though we want these functions to be generalized as possible, these are set up to only be looking for the largest of a thing, or this one is supposed to be. So big string is going to be a string, a big number is going to be a number. Actually, we can't give it the number 0 because that may break it. Okay, so number is the thing, just like before, when we're looking for the longest word, number is the thing we're comparing the whole way. Big string is just going to grab whatever name is at the same position in the other list. But the one we're comparing is the number, which the number is list 2. So we need to give it list 2 index 0. We need to give it the first thing in list 2. List 2 index 0. Now we need to go through the entire list, and we can do dot length of either list. This is just how many times we're going to loop, and we know list 1 and list 2 are the same length. So just whatever, list 1 dot length number of loops. And every time everything at every position in the list, we are checking to see if list 2 is our one with numbers. List 2 index I, if the new one we're looking at is greater than our running champion, which is big num. We're almost done, folks. Okay, list 2 is the list of numbers that we're checking. If the one we're checking, index I, is greater than our running champion, we want to give our container that's holding the running champion whatever one we're looking at, which is list 2 index I. And we also want to give, when we have a situation where we are updating big num with the new biggest number, we want to get the string at that same position, which is list 1 index I. Because I is whatever sort of essentially row we're looking at. And it is important to name it list 1 index I. It'd be very easy to make it like list I index 1 or whatever. But list 1 is our list of strings. List 2 is our list of numbers. And the number is what we're comparing against. It just happens that this list of strings is coming along for the ride, whichever one we want. And then we are returning, what are we expecting to return? A string. Oh, we are only interested in returning the string that corresponds to the mostest of whatever we're checking. And so let's zoom out a bit. Largest maximum. Is it only expecting 2 parameters? It is. So, well, let's see what happens. Okay, the largest population, California, and Tuvalu, and China. All right, so it works. There we go. If you're not sure what's happening here, that's fine. Just work through it and listen to the words, and doing what we're doing in class during class is a great first step.